Hello, good morning students. Myself, Dr. Niranjan RS, Assistant Professor, Department of Physics, Government First Grade College for Women, Vadanarshipura. In this session, I am going to discuss about the numerical problems of the topic conservation of energy. First, we will discuss the first numerical problem, that is, calculate the altitude of an artificial satellite if it is always at a fixed place with respect to Earth. The given values are g is equal to 9.8 meter per second square and radius of the Earth is 6400 kilometer. Solution for this problem is the angular velocity of the Earth is given as, we already know, angular velocity omega equals root of gm over r cube, or it is also written as g is equal to gm over r square. Substitute this gm value in the angular velocity equation and rearrange. We get r value, small r value, that is equal to small g capital R square divided by omega square to the power of 1 over 3. Substitute the values. Small g equals 9.8, capital R radius of the Earth, it is 6400 kilometer. Then omega means angular velocity, that is 7.268 into 10 to the power of minus 5. Substitute all these three values and calculate. We get the R value, that is altitude of the artificial satellite, which is at a height of 41,749 kilometer. Second problem, calculate the velocity with which a planet has to be launched from the surface of the Earth so that it escapes from the gravitational influence of the Earth. Given radius of the Earth is 6400 kilometer. Solution for this problem is escape velocity of the satellite is ve square is equal to 2 capital G capital M divided by R, or escape velocity have another relation, that is root of 2 small g capital R. Escape velocity, if we substitute the value of small g and capital R, acceleration due to gravity small g is 9.8. Capital R is the radius of the Earth, that is 6.4 into 10 to the power of 6. That is, if we simplify this, we get the value of the escape velocity from the Earth's surface, that is 11.2 kilometer per second. If we look into the next problem, the problem 3, a remote sensing satellite of the Earth revolves in a circular orbit at a height of 250 km above the Earth's surface. What is the orbital velocity of the satellite? Given is radius of the Earth is given, that is 6400 km, and acceleration due to gravity on the Earth's surface is 9.8 meter per second square. Solution for this problem is, we know that orbital velocity is equal to root of small g capital R square divided by small r. Orbital velocity, if we substitute the value of small g capital R and small r, all these three values are given, but small r value is not given. So this smaller value we have to calculate by adding the height, that is 250 kilometer from the earth's surface and 6400 kilometer from the center of the earth to the surface of the earth. These two, if we add this, we will get 6.65 into 10 to the power of 6. Substitute the smaller value and calculate, we get the orbital velocity of the satellite is 7.769 kilometer per second. We look into the next problem, that is the fourth problem. Earth revolves around the sun in an orbit of radius 1.5 into 10 to the power of 11 meter with a time period of 365 days. Calculate the mass of the sun. G, it is given 6.67 into 10 to the power of minus 11 Newton meter square per kg square. The period of revolution of the earth is given by T square root of 4 pi square r cube divided by capital G ms. Ms is the mass. Ms is equal to 4 pi square r cube divided by gt square. If we substitute the value of pi 3.14, smaller value, that is 1.5 into 10 to the power of 11, and then capital G value given 6.67 into 10 to the power of minus 11, and the T value, it is 365 days multiplied by 24 into 60 into 60, it is converted into seconds. We will get 3.1536 into 10 to the power of 7. Substitute all these values and calculate, we get the mass of the sun equals 2 into 10 to the power of 30 kg. We look into the next problem, that is problem 5. What will be the acceleration due to gravity on the surface of the moon if its radius is 1 by 4th and mass is 1 by 80th of that of the earth? Acceleration due to gravity, solution for this problem is G equals capital Gm over r square. Take the ratios of G in the moon and as well as on the earth. If we take the ratios, capital G and capital G get cancelled. We left out with re square divided by me rm square. Substitute the value of rm and also substitute the value of mm and simplify. We get the ratio of G, M and GE, acceleration due to gravity in moon to the acceleration due to gravity on the earth, that is 4 square divided by 80, that is 16 divided by 80. It gives the value 1 by 5. Therefore Gm equals 1 by 5 GE. These are the problems we took from these 4 books. These are the references. To solve more problems, you go through these references. Thank you.